Welcome everybody to already the last lecture in the series about the 4 essential effects of programming. What I want to do in this last lecture is talk about the observable contract. And that's the behavioral contract about observable streams that is not visible in the type. The type signatures of observable and observer, and specifically of observer, just says that you pass 3 callbacks on next, on completed, and on error, and they get called. But nothing in that signature tells you in what order they are called or what the guarantees are. And similarly, when you subscribe to an observable, you get back a subscription. We did look at the algebra of subscriptions, but we didn't talk about what the observable stream does with these subscriptions. And we're going to drill down a little bit into that in this lecture. And the lesson of this lecture is that you should never, ever implement observer or observable yourself. You should always use the factory methods that the library provides, because if you do it yourself, there's a very, very high probability that you don't satisfy the contract and something will go wrong. So that's really what I want to kind of drill in your heads. Don't ever implement observable or observer yourselves. And the same for subscription. And the same for all Rx types. Only use the factory methods that the library provides. So let's kind of see why this is not trivial. Okay, so here is a example of how you naively could implement observable.create. So remember, observable.create takes a function from observer to subscription, and it needs to create a new observable. Well, you can say, that's easy, because I just defined subscribe that takes an observer. Oh, and I have a function that takes an observer and returns a subscription, and subscribe should return a subscription. Oh, then I can just pass the observer to that function to get a subscription, and I'm done. Well, it would be great if life was so easy, but that's not the case. So if you look at the actual implementation, there's a lot of implementation details here that are wrapped around the function and the kind of passing of the observer to ensure that the Rx contract that we're talking about in this lecture is satisfied. On the other hand, if you're using observable.create, when you're reasoning about it, it is kind of pretty safe to kind of just unfold it like this. So when you do observable create with some function, and you subscribe to that with an observer, you can kind of say that's more or less the same as passing the observer to that function. Okay? But there's still all that implementation detail. But this is the conceptual model. But the actual implementation is not this simple. And the same is true for the observable apply, which took a function that takes a subscriber and returns unit. So when we subscribe to that, we get an observer. So now, at least, we must wrap the observer in something to make it a subscriber, pass it to F, and then there's also a lot of kind of implementation details that wrap around this to ensure that the contract is satisfied. Now, what is this contract? I mean, I've mentioned this word now several times, so let's look at one thing. So one thing is the behavior of the subscription that you get out of subscribe. And in Rx, we implement the so-called auto-unsubscribe behavior. That means that if, in this case, let's look here, if you call onComplete on this observer, or you can call onComplete or onError on the subscriber that gets passed in, that the subscription that gets handed out is automatically unsubscribed. So here's how you can test that. So here we implement observable.empty. So as we know, it took a subscriber, and it immediately calls onCompleted. Now we say s equals empty.unsubscribe, and then when we print is unsubscribed, we will see that it is immediately true, even though we have not unsubscribed from s. But the reason is that, you know, there's the auto unsubscribe behavior here. And notice I promise you there would be typos in the slide, and there is obviously an equal sign here in white ink. It's there, I promise you, but it's just in white ink so you can see it. All right, so here are some other issues with the Rx contract. Since, you know, there's these three callbacks, on next, on error, and on completed, we guarantee that they are called in a certain order. So we guarantee that the stream has the following structure. So we call on next 0 or more times, and then optionally we call on completed or on error. So it might be that in the case of never, that nothing is called, so that's you know, never calling anything. That is a valid instance of this expression. Or you can call on next, you know, multiple times, but never call on completed on error. Or you can call the normal case on next many times, followed by on completed. Or you can call on completed directly, that was empty, or on error directly, and that was error. All right? But it's always in this sequence. So after you've seen an on completed or an on error, you will never see any of the other methods anymore. So once on completed has been called, you can be sure that on next, on completed, and on error are never called. And that's the reason that we do this auto unsubscribe, because we know that the stream is done, and so we kind of eagerly unsubscribe for you. So these are the two kind of, you know, valid instances. There's a number of on next followed by on completed. There's a number of on next followed by on error, and of course there could be no on error and on next. The last part of the Rx contract is the fact that on next and on completed and on error are called sequentially. So there will be never overlapping calls. So they are always serialized. So if you get here on next, the next on next will only be called when the first on next will be finished. So there's never overlap. So you, inside your callbacks, you never have to kind of, you know, worry about concurrency, because the Rx library serializes everything for you. And if you look at the implementation, you will see that we go through great lengths not to use logs, but try to do everything log-free to make that efficient. So maybe another way to look at Rx is just like a fancy library that kind of takes care of serialization of concurrent notifications for you. We don't have time to go into all the details of the Rx contract and all the kind of, you know, API design guidelines. But you can go to either the ReactiveX website or the Rx wiki, or there's the original, the Bible of Rx, the Rx design guidelines. If you Google for Rx design guidelines, you get a PDF document that explains the guidelines in terms of rx.net. But they are all valid for every implementation of Rx. So let me finish by saying that Rx here in this course, we showed you Rx Scala. That's based on Rx Java. As I warned you, the names in Rx Scala are often different. The identifiers and method names are different than in Rx Java. But the semantics are the same. We just made sure that the API feels natural for Scala programmers. But on the JVM, we have a whole slew of implementations. Rx Java, there's bindings for Kotlin, for Clojure, for Groovy. You name it, any language that runs on the JVM has Rx bindings. And then there's also ports of Rx in other languages. Rx Java, in fact, is a port of the original Rx.NET. And there's Rx for C++. Also very popular is Rx for JavaScript. But there's also Rx for Python, Rx for Ruby, and there's Reactive Cocoa done by the friendly people at GitHub. That is an implementation of Rx for Objective-C. So all the concepts that you learned in this lecture, you can apply in any language. So you're not kind of stuck with Scala or .NET or with Java. It's the general principles apply to any language, and the framework has been ported to any other language. And often, you know, when you're building a web application, your client is written in JavaScript. You can use RxJS there. Your server side is written in Java. You use RxJava or RxScala there, and then you can communicate. Okay, so one last warning. Never ever implement observable or observer yourself, or in fact any of the other Rx types, because you will violate the Rx contracts. I guarantee you. So when you do a code review and you see somebody kind of write naive code like this, where they say, oh, I need to create an observable just by kind of implementing the subscribe method, that alarm bells should go off. You should never ever do that. Okay? So really use only the factory methods. Okay. Thank you so much for your attention. I hope that you enjoyed these lectures, and I want to kind of remind you here one last time about the 4 effects of programming. The first column here was computations that return one value. If they do that synchronously, we started out with blocking methods that didn't kind of in their type show that there could be an exception. And then we introduced the try monad that made exceptions explicit. All right? Then we went from try and said, hey, there's also the effect of latency. Remember the table where sending a packet from Europe from the US to Europe and back would take several years. So we have to make latency explicit in our types. And for that we used future of t, which represents a computation that can fail and takes a long time. And there we talked about a lot of combinators on futures, etc. And we introduced async await. And async await allowed us to still write normal control flow. And the reason that we could do that is because futures return only one value. Then these two here were related by the magic trick of duality, where we reversed the arrows. And then we moved from the one side to the many side. And we started with iterable. Those are the synchronous streams, where you're pulling values out of the streams, and that might block. So say that you're pulling strings out of a file. That will take, in human time, days or months or years, so you should never do that. And so we reused the dualization trick here to go from iterables to observables. And we talked quite at length about also all the higher order functions and details of observables. Okay, so I hope that you can apply this knowledge in your day-to-day programming. I hope that it gave you a little bit more insight in the essence of effects. And so I leave you here with my motto: happy hacking, and use the force. Bye bye.